Hello friends, this was the MCQ that I had posted on all my social media platforms this week that has gone by. The MCQ was related to the CVS, and to be precise, it's related to the Windkessel effect. So let's check out the MCQ and figure out what's the answer. A healthy person has a blood pressure of 120 by 80 mm of Hg. So baseline blood pressure is given, and then a tiny plaster cast is applied to his aorta. Now that's hypothetical, but we got to understand the concept behind it. So a tiny plaster cast is applied to the aorta. What will be his blood pressure now? And they have given 4 options. The question is 130 by 90 means it is suggesting that both systolic and diastolic pressures will rise beyond their baseline levels, or 110 by 70 means systolic and diastolic both pressures will fall after the application of that tiny plaster cast, or 130 by 70 means systolic will increase but diastolic will decrease, or 110 by 90 means systolic will decrease but diastolic will increase. And when we say increase or decrease, it is with reference to the baseline blood pressure which is already given to us. So let's understand this MCQ in detail now. This particular MCQ was related to the Windkessel effect. Now Windkessel is a kind of a pump reservoir, but in physiology and medicine it is used for certain blood vessels. Aorta and large arteries, they show Windkessel effect, and therefore those vessels are called as Windkessel vessels. Let's understand what this Windkessel effect is. Left ventricle, when it goes in systole, it ejects the blood into the aorta. Now aorta will distend and accommodate this blood which was ejected out into the aorta. That's the first part of the Windkessel effect. Aorta will distend and accommodate this blood. And then, just to make a point here, left ventricular pressure will rise with systole, and therefore aorta pressure will also rise to certain extent because of the blood coming in. But because aorta is distending and accommodating that blood volume, therefore the pressure will not rise much. Pressure will become a systolic pressure in the aorta and arteries, but it will not be a great rise of pressure because of the distensibility, because of the compliance of these vessels. They accommodate that blood without allowing the pressure to rise much. That's the first part of the Windkessel effect. And then when the left ventricle goes in diastole, aorta will recoil back and push this blood forward. The potential energy in this blood will be converted into kinetic energy, and the blood will be sent forward, pushed forward. That is how blood circulates through the vascular tree. So one part of it during systole, the other part of it during diastole. And because it is sending the blood forward during diastole by recoiling back, blood does not accumulate at one place, and therefore pressure falls with diastole, but it does not remain high because blood is moving forward, does not accumulate at one place. Now let us understand the effect of this MCQ. A tiny plaster cast is applied to the aorta. Now you know plaster casts are used in orthopedics whenever the bones are injured. To keep the limb stiff, the plaster cast is applied. So same thing is expected here. When you apply this so-called plaster cast, it's a hypothetical question actually. So let's say we have applied that plaster cast over here. Now you will understand what will be the effect. It means we are not going to allow the aorta to distend with systole. We have stiffened the aorta. Aortic compliance is reduced now. distensibility of aorta will be less. So now what happens is, when the left ventricle ejects the blood during systole, now aorta cannot distend and accommodate that blood. So the aorta pressure will rise during systole. It anyway rises, as we have seen, aorta pressure does become some 120 mm of Hg, because that's the pressure in the left ventricle. But now it will increase much further because it is unable to distend. And then the second part also is not possible. Look, aorta was distending and then recoiling back. If the aorta now does not distend, there is no question of recoiling back and pushing the blood forward. So that means during diastole also quite a lot of blood will accumulate in this region, and that means more the blood volume, greater will be the pressure. So diastolic pressure, which was normally 80 mm of Hg, is expected to now become 90 mm of Hg. Look, let's get it straight. Diastole, the pressure falls in the left ventricle, in the aorta, in the arteries. That's fine. It falls up to 80 mm of Hg. Now, because that recoil effect was not there during diastole, blood remains in greater volume in the aorta and arteries, and therefore the diastolic pressure rises in the sense that if it was 80, now it will become 90. So systolic pressure also rises and diastolic pressure also is higher. Rises means higher than what it was expected. So 130/90 was the answer to this question, and this is the same effect that will be observed even with the atherosclerosis. In atherosclerosis, the vessel wall is stiffened. So an effect like this plaster cast, and therefore if atherosclerotic vessels are there, then systolic and diastolic pressures increase, and this is why there is hypertension. So that was the concept behind this particular MCQ.